Okay, so hi, this is Sean Mullery from Electronic Engineering at IT Sligo, and I'm going to show you graphically what happens in the linked list program. So I'm going to start here with the main function, as you can see here, and what we've got is we've created a list node pointer here and we've called start pointer, and we've assigned it the value null. Okay, so that's basically a pointer to a list, that's basically a pointer to a list node. And what we're going to do with that later on is we're going to be able to modify that. That's going to be basically the start of our list. What we do is we give them some instructions here, as you can see, and we then ask them for a choice, and the choice goes in there in the scanf as %, it goes in choice. What we then do is we look at the choice, and if it's the first case, which is this situation here, case number 1 here, so we'll just look at that a little larger here. We can see that we're asked to enter a character, so that's the letter that we're going to put in, and we're then going to put that into item. We then call the insert function, and the insert function is, this is one of the most important bits here. It's not sent the start pointer itself, it's sent the address of the start pointer. Now the start pointer is a pointer, so it is already holding an address. We, however, are sending it the address of that address. Okay, and the reason that we do that is that we need to be able to have that function modify the address that's in there. Okay, so modify the pointer. This doesn't happen in the print function because we don't need it to modify it, but we do have to modify it in situations where we're actually creating the list. That's why we have the ampersand there. So that's known as a pointer to a pointer because we've got the address of the pointer. We also send the item here that we're going to actually send, which is the character that we've put in. Okay. So this calls the insert function. So what I'm going to do here is I'm going to show you the insert function. And you can see the insert function here. And it's got its list node pointer up the top here, and it's got the character value. Now it's changed it from item to value, but that's the only change. So now we know it has value. And the first thing we do here is we create 3 pointers to list nodes. The first one is called new pointer, the next one is called previous pointer, and the one below that is called current pointer. And of course we still have SPTR, which is the start pointer itself. You'll notice that that's an asterisk, even though that start pointer is already a pointer, it's got an asterisk there, and that's because it's a pointer to a pointer. Okay, so what I'm going to do is I'm going to go up to my little diagram area here, and I'm going to draw those for you here as best I can. And I'm quite new to this this pad system that I'm using here, so hopefully you'll bear with me. So I'm going to just put my start pointer here first of all. Okay, and what I'm going to do is I'm going to put a little thing just on the end of that there. Let's see if I can move that now. And not very easily is the answer to that question. Just going to push it up so that it's tight against it, and the reason for that is what I'm going to put in there is what we're actually pointed at. Okay, so that we always know where we're going. Now the what we're also going to do here is we're going to create the 3 different pointers that we had there, which were the new pointer. So I'll just put that there. I'll also create the one called current pointer. And we'll create the previous pointer. I might try doing it with the text here. We'll just see. Allow me to do that. Okay, it does. Maybe that might be the better way to write it, rather than my poor handwriting. Okay, so we've got the previous pointer, the new pointer, and the current pointer, and that's all we've done so far. Now, this next line here, new pointer is assigned list node pointer malloc size of list node. This is going to create a new list node, and when it does create it, it's going to send the address of that to the new pointer. It's going to put the address of that into the new pointer. So that's the next thing we're going to do here. So once again, I'll draw a little square here. And now, the list node pointer, as you know, has a character in it called data. Just wait for this to save. So it has data in it, but no data, no actual value in it yet. And it also has a next pointer. Okay. And what we do is we assign the new pointer to this piece of information here. So that means that we're now pointed at that. Okay, so that's where we're now pointed to, following the beginning of the insert function here. Okay, now there is of course the possibility that it didn't create that list node there, that it couldn't find the memory to do it. And if it couldn't find the memory to do it, the new pointer would be equal to null, in which case we would go down to the else statement here and say that %c, which was whatever letter we put in, was not inserted, no memory available. Okay. However, we're going to assume that it did do. Now, the other thing we're going to assume is we're going to pick a letter, and I'm going to pick the letter K, and I'm going to assume that the letter K was put in. Okay, so we've gone into here and we say new pointer's data is assigned value. So just go back up here. Okay, so follow new pointer along here. Okay, so new pointer's data. So following the line there, new pointer's data was assigned K. So I'm going to write K there, little dashes. That's the information that's gone into K there at that point. Let's go back down now to the next thing we do is we say new pointer's next pointer is assigned null. So remember, new pointer is pointed to this struct here, and its next pointer is assigned null. So what I'm going to do is I'm going to draw a little line here down to here, and I'm going to have null written here. Okay, so that's our null pointer. That's the end of the thing. Now, what happens next? Well, the next thing that happens is that the previous pointer is assigned null as well, and then the current point. So we'll do the previous pointer first. So I'm just going to draw a little line from there, from the previous pointer down to null as well. Okay. The next thing that happens is that the current pointer is assigned whatever's in SPTR. So in other words, the value of the start pointer. Okay. Now the start pointer is we'll just check in the main function what was the start pointer. Did it have a value? Okay. And if you remember here, it had the value null. Okay. So I'm going to show that here by just writing it in here on the start pointer. Just going to write null here. Okay, so the current pointer is assigned whatever's in the start pointer, which is null at the moment. So that basically means that it's going to be attached to null as well. Okay, so all three of them are now attached to that. Now at this point we have a little while loop here, and you need to look at the two items in the while loop to decide whether it's going to continue. So it says current pointer is not equal to null. Okay, now we happen to know the current pointer is equal to null at the moment. As you can see there, current pointer is equal to null. So therefore, immediately, that while loop becomes not true, and we jump straight down to here. Now, if the previous pointer is equal to null, and is it? Well, if we look back up here, you can see the previous pointer is indeed attached to null, as you can see there. Okay, so because of that, we're going to do that little section of the program. Okay, so previous pointer is equal to null. So what we do in this case is we say new pointer's next pointer is assigned whatever's in S pointer. Okay, that's what the asterisk obviously is, whatever's in it. So new pointer's next pointer is whatever's in S pointer. Okay, so new pointer is pointed to this, its next pointer is here, and it's given whatever is in start pointer, which is null. So in actual fact, that's already set up that way, so nothing changes. Okay, now you might think that's unusual, but that's because this program is set up to deal with all sorts of situations that we might have. So that's all finished. Or sorry, the next thing is that whatever's in the start pointer is assigned new pointer. So that is important. Sorry, while I get used to this scrolling around this. Okay. So start pointer. We want to remove what's in that, and we want to give it what new pointer is pointing at, which is effectively that. So I'm going to do that by just want to make sure that this is I'm just going to delete this. And what I'm going to do is I'm just going to write in data k here, just to remind us that it's k we're pointing at the moment, because it's given whatever's in that. So it now points to there. Okay. At that point, we're finished the insert function, and we leave it, and we would go back to main again. Okay, so that's us done. Now, what we're going to do is we're going to insert a number of these, and we're going to move around them as quickly as possible. So what I'm going to do in the next case is I'm going to insert, so we've already inserted the letter K. The next letter I'm going to insert is going to be H. Now H comes before K in the alphabet, so that means that in ASCII terms it is a smaller number than K. Okay, so the new value that's going to come in is going to be that. So we'll just take a look back here at the insert function. What we do at this point is we recreate our new pointer, our previous pointer, and our current pointer. What's going to come in here is H, and we're going to be sent in the SPTR, which is wherever it's currently pointed. Remember, that got modified back at base. So we create a new pointer, previous pointer, and a current pointer. So where on my diagram they're currently pointing at particular places, we need to get rid of that because these are new again. Once we come into this function, these things are recreated once more. So I'm going to get rid of that, and I'm going to get rid of this. Okay. Now you should be able to spot that even though I've come in here and I've created a new pointer, new current pointer, and new previous pointer, my start still points to the k and the next pointer points to null, so my list is somewhat intact. So I've created a new pointer, a current pointer, and a previous pointer. Now I'm going to create a new list node. This is for where the h is going to go, but in this particular, what happens here is that we create the space for it first and then we assign it to new pointer, but we don't actually put in the information just yet. So once again, I'm going to create thing and one of these, and I'm going to create it roughly just here somewhere. There's my data, no data in it at the moment. Here's my next pointer. And what we do here is we have new pointer is pointed to it. Okay, so that's there. We're assuming it's not null. We're assuming that the malloc was able to happen. So So what we do next is we say new pointer's data is assigned value and new pointer's next pointer is assigned null. So let's do the two of those. Okay, so new pointer followed the line new pointer's data is assigned value, which we said was h, and new pointer's next pointer is assigned null. That goes down to there. Okay. The next thing that happens is we say previous pointer is assigned null and current pointer is set to whatever's in SPTR. So previous pointer is assigned null, that's down to here. And current pointer is given whatever's in S pointer, which is currently pointing to K, so that's what we're going to point to as well. Okay, so it's pointed there. Next, we go through this while loop sequence again. Now, the first thing we do is we check, is the current pointer not equal to null? And as you can see there, the current pointer is definitely not equal to null there. It's equal to the data in with K in it. So that's fine. Is the value bigger than the current pointer's data? Now, the value is H, because we just brought it in. The current pointer's data, though, is K. Now, is H bigger than K? It isn't, because it's lower down in the ASCII set, so therefore that's not true. So coming back to this while here, that while has now failed again. We haven't got into it. So we've got down to the next if statement here, which is if the previous pointer is equal to null, and currently the previous pointer is equal to null. So we're going to do whatever's in this one. So new pointer's next pointer is assigned whatever's in S pointer. So that means that new pointer's next pointer, remember it's currently pointed to null, so we're going to have to take away that, its next pointer. So it's pointed to whatever's in S pointer, which is currently pointed to K. So that means that an arrow goes up here and round to there. Okay. And the next thing then that happens is that whatever's in S pointer is pointed to new pointer. Whatever's an S pointer is pointed to what new pointer is pointed at. And new pointer is basically that address there. So that basically means that I come in here and I get rid of my K now. And I get rid of what it's pointing at. And now I put in the letter H here, because that's what I'm going to be pointing at now. And I'm pointing at that, so I'm pointing down to here. Okay. Now, basically, if we watch the diagram now, the start pointer comes in, it's pointed at the data in H, its next pointer is pointed to the data K, and its next pointer is pointed to null. So that's the list. And at this point, we're finished with the insert function at that point. So we're gone out of there, and once we leave the insert function, the new pointer and the current pointer and the previous pointer are effectively deleted. They're gone. So I'm going to take out their thing as best I can. Wipe out that. I'm going to wipe that out as well. And I'm going to wipe out the previous pointer. And it's gone as well. So you can now see, I know I've tiny little breaks in the thing simply because I've cut it out, but we'll do our best to put them in again. So the start pointer goes to data H, its next pointer goes to data K, its next pointer goes to null, and that's your list now. So we'll insert another item, and what I'm going to do is I'm going to insert something in between the two of these. So I'm going to insert the letter I. Okay, so that's going to be my next one, and again we're going to go to insert here. And as you can see, insert again creates a new pointer, a previous pointer, and a current pointer. So we've done those up above, and what we also do then is we create a new node and we set that to new pointers. So that's what I'm going to do here. So data here again, and next, its next pointer, and we assign a new pointer to that. So new pointer is now pointing at that. So that's that bit there. Again, we're assuming it's not null, that we were actually able to create it into the thing. The next thing we do then is new pointer's data is assigned value, and new pointer's next pointer is assigned null. So new pointer's data is assigned the value, which is I, and its next pointer is assigned null, so it's pointed up to there. Previous pointer is assigned null, and current pointer is set to whatever's in S pointer. Previous pointer is assigned null, and current pointer is sent to whatever's in S pointer, which is basically that one there. So it's the two of them are the same now. So current pointer is pointed to data H. We go to this while loop again. We ask, is the current pointer equal to null? Well, we saw there that it isn't. It's equal to the data H. And is value, which is I, bigger than current pointer's data? Current pointer's data is H. And as we go through the alphabet, HI. So I is a larger number, so that's also true. So both of these are now true. And that means we get to do what's in this while loop. So the previous pointer is, what we do then is the previous pointer is assigned the current pointer. That's the first thing we do. Which means I come in here with my little glantor. Which for those of you who never learned Irish is basically a whiteboard eraser. Okay, and get that out there. And so we said previous pointer is assigned current pointer, isn't that what we said? Previous pointer is assigned current pointer. So previous pointer is assigned to the same thing as here. And what happens then is current pointer is assigned current pointer's next pointer. So we get current pointer's next pointer first. So current pointer follow it, that's its next pointer, which is pointing up to data K there, and that's what we now set current pointer to. So we erase whatever's there, and we now set current pointer up to there. Okay, and again we go around the while loop. And we now say, is current pointer not equal to null? Well, we know it's not equal to null. We just set it equal to K. And we check, is value bigger than current pointer's data? And current pointer's data is K. So is I bigger than K? Well, I comes before K in the alphabet. And therefore, it's not bigger than it. So therefore our while loop stops at that point, and we come down to the next set of if statements. So we check, is previous pointer equal to null? Now in this case it isn't. Previous pointer is equal to the data in H. So no is the answer to that. So we go down to the else then, and we do whatever's here. So previous pointer's next pointer is assigned new pointer. Previous pointer's next pointer, okay, is assigned new pointer. Just check that again. You can see it there. So what that means is that previous pointer's next pointer is currently pointed up to k. We need to get rid of that. And instead we wanted to point to what new pointer is pointed at, which is this one here. The next thing we want to do then is we want to say new pointer's next pointer is assigned current pointer. So new pointer's next pointer is assigned current pointer. That means it's currently pointed to null. So we need to point it to the whatever the current pointer is pointed to, which is the data in K, which is up to there. Okay, and that finishes the insert function for that. What we have then at that point is we again get rid of the new pointer, the current pointer, and the previous pointer. So we're going to delete the lines from those so that we can see clearly what's happened. So current pointer is gone. New pointer is also gone. And previous pointer is also gone. And if we follow it, start is H. From H we go to I. And from I we go to K, and then we go to null. So you can see that the list continues on. Okay. Now I think what I'll do is I'll add perhaps one more item. Although I think we've tested pretty much all the different things. We've gone through the while loop, we've gone through this. But what I'll do is I'll just add something a lot further on. So I'll add something at the very end of it, just to show it. So I'm going to add an X here. I'm going to add an X just to show that. So hopefully you've already got it at this stage. But if you haven't, this last one will give you a little bit more insight into it. So again, we come into the insert function and we create a new pointer, a previous pointer, and a current pointer. And the malloc function here is going to create the new list node, which is going to be assigned to new pointer. So somewhat running out of space here, but I'll create it down here. And this is data. And we assign that to new pointer, if you recall. That's so new pointer is now pointed down to there. The next thing then that happens is that we say new pointer's data is assigned value and new pointer's next pointer is assigned null. Okay, so new pointer's data is assigned the value, which was X, and its next pointer is assigned to null, which has gone to there. Okay. Previous pointer is assigned null and current pointer is assigned whatever's in S pointer. So previous pointer is assigned null down to there, and what did we say? We said current pointer is assigned whatever's in start in S pointer, which is going down to there. As you can see, so we're now S pointer and current pointer are pointing in the same direction. Now Now we go through our while loop here, and this while loop is going to have to go through a good many of them before it finds what it's looking for. So the first thing we say is check that current pointer is not equal to null. It definitely isn't. It's pointing at the data in H, and we see is the value. Remember, the value is x. Is that bigger than current pointer's data? Now x is a long way down in the ASCII, so it's definitely higher than H, which is current pointer's data. So therefore, yes, both of those are true. Therefore, my while loop must happen. Now in my while loop, my previous pointer is assigned my current pointer. So as you can see here, the previous pointer is at the moment pointed at null, so we need to delete that. Okay. And we need to point it at what current pointer is pointed out, which is that one there. Okay. Then the current pointer is assigned current pointer's next pointer. So we get current pointer's next pointer first. So current pointer is pointing at data H. Its next pointer is data I. So we remove that link there, and we set current pointer equal to that. Okay. Back to the while loop. Is current pointer not equal to null? It's definitely not. It's equal to I, so that's fine. Is value, which is I, or which is x, remember, is it bigger than current pointer's data? Well, the current pointer is pointed at I. Is x bigger than I? Yes, it is. So therefore, once again, both of these are true. So the previous pointer is assigned the current pointer. So again, so it's pointed to what the current pointer is pointed to, which is down there. And the current pointer is assigned the current pointer's next pointer. So we go through, current pointer is pointed down to here, its next pointer is pointed up to data K, so therefore I remove the link with the current pointer in it. And I set that up to there. Okay. Once again, I go back to the while loop. Is current pointer not equal to null? Well, we know it's not equal to null. We saw there that it's equal to the data in K. And is value bigger than current pointer's data? Current pointer's data is K, and the value is X. So X is definitely bigger than K. It's further down the ASCII chart. So again, the previous pointer is going to be assigned the current pointer. I'm sure you're getting the hang of it now at this stage, I hope. So the previous pointer is going to be gone from there, and it's going to be given the whatever the current pointer is pointed to. So it's going to be pointed up here to this. Meanwhile, the current pointer itself is going to be pointed to the current pointer's next pointer. Okay, so the current pointer is pointed up to here. Its next pointer is, as you can see, is pointed down to null. So which means the current pointer is now going to be pointed down to null. Now, once we're out of there, we ask, is previous pointer equal to null? No, it isn't. So, sorry, just to go back around, apologies. So we've done that, we come back around here. Is current pointer not equal to null? Well, it is equal to null now, as you've seen there. So current pointer, sorry, just move it to there. Current pointer is equal to null. So you can see it's gone round to there. And therefore, that while loop fails at that point. So we come down here, then we check is previous pointer equal to null. It isn't. It's pointed to the data up there at K. And so we do this one down here in the else. So previous pointer's next pointer is assigned new pointer. Now, so remember, now I've kind of damaged the line there, but that was pointed up here. Okay, so previous pointer's next pointer is assigned to the new pointer, which is down here. So that means that I get rid of this line here. And I assign that there, and it comes around here all the way around and points to that. Okay, which is new pointer, what new pointer is pointed to. And lastly, what we do is new pointer's next pointer is assigned current pointer. So new pointer is this one, its next pointer is currently pointed to null. We need to get rid of that. And you'll find that we'll be recreating it because we said it's equal to current pointer. Current pointer, because we're at the end of the thing, is equal to null, so we're effectively drawing that back in again. And we're there. Okay, now that would complete the insert function. So what I'm going to do at that point is once again delete or get rid of these things here. And previous pointer. Okay, so and just to draw back in some of these lines, so start pointer comes down here, it goes to data H, which goes to data I, which goes up to data K, which comes down here to data X, and then from that it goes to null. So you can see our linked list is maintained. Okay, so I'm going to end the recording at that, and in the next recording I'm going to show you, I'm going to start from this point and we're going to delete an item for you just to show you that.